Okay, so today I'm going to be talking briefly about how to use R projects in RStudio. So what are some of the reasons that you would want to use R projects? Well, R projects help you deal with a common problem that is always present when you're working in any programming language, which specifically is how you manage your working directory. There's other benefits as well, but that's the main draw for most people most of the time. So let me go ahead and get a completely clean R environment here. So you can see I'm actually in a project right now. So I'm going to close that. And now I'll be in a completely clean R environment. Okay. So now I'm in a home directory for R, which is, as you can see here, my actual documents folder. And how do I know that? Well, if I do get WD, which stands for get working directory, I can see right here, I'm in C users MILLE documents. And that is in fact my home directory from the perspective of RStudio. And the reason that I know that is one, because I can see it says home here, but the other reason is because I can see it says ~/. Does anybody know from, maybe you used Bash before, maybe you used some other Linux before. Does anyone know what the tilde means in Linux?
Isn't it just like a relative thing? I'm not exactly sure though. It's like it kind of just it says it like the home. It's like your home.
Yeah, it's your home. Here, I'll actually show you this. So I'm going to log into my Linux server. All right, so if I go, I'm going to go into a directory. I'll go into R and I'll go here. Okay, so now I'm here. If I want to go back to my home, all I have to do is type CD ~/. And now I'm back into my home. So hopefully that kind of makes sense. The ~/ is just a way of saying your home directory in like a Linux environment. And so it kind of translates nicely over to R, which is based on Linux, and which most people are developing for it in Linux. So this is a nomenclature most people are pretty familiar with. But anyways, so the purpose of having a home directory in R is that anytime you open up R, anytime you open up a new R console or R environment, you have a place to start from. But most of the time, we don't actually want to work in our documents folder because it's messy, it's full of stuff, and it's not really where most of us are going to be working on projects. So instead, we could set our working directory to be somewhere that is more usable from a project point of view. So to do that, you can do set WD. And anytime you open up a pair of double quotations in R, if you hit tab, it'll show up with the file browser. So you can actually easily find whatever folders or whatever locations in your file system you're looking for. So let's say I want to go to this miscellaneous folder. And there's nothing else in here. So if I hit tab, I can see there's nothing else in here at the moment. So let's say this is where I want to do a project. So right, I've now set my working directory as my miscellaneous folder within my documents folder. And we can now see that if I type get WD, that is true. So let's now create a file. Let's see here. I'm going to go in here. Okay, so I actually do have some data in here already, which is great. So if I want to, I can go ahead and run one of these files. I can go ahead and open them up and work on them. Let's go and do this now in RStudio. We'll make a new R script. And you can do that by clicking, or you can just hit Control-Shift-N if you're on Windows. And when I go to save it for the first time, it brings up the miscellaneous folder, again, telling us we're in our miscellaneous folder. That's our working directory right now. Okay, so I'll call this my new R file.r. And let's say that I want to save some data. So I'm going to load up the iris dataset, which Does anyone know, just before I jump into it, and hopefully you didn't see that description there, does anyone know what iris is?
Is that like the flower thing?
Exactly, yeah, yeah. Does anybody know what kind of object it is in R though?
It's maybe a tibble, but it's built into R, I think. So probably not a tibble, just a data frame.
So yeah, I let's go ahead. I'm going to show you how I actually do this. So I'm gonna do class of iris. So iris is an object. Everything in R is an object. It's an object-oriented language. So let's see what it is, and it's exactly what Victor said. It's a data frame. So you can make it into a tibble if you do. If we do the let's see here. Apparently as.tibble is deprecated. There we go. Do it the proper way. All right, so now we've made it into a tibble. Okay, anyways, so I don't want to get distracted. So basically, because my working directory is this miscellaneous folder, and we can see this, it says now ~mis/, so showing that I'm in my home directory, and then I moved from my home directory into the miscellaneous folder. So now I'm inside the miscellaneous folder inside my home directory, which is just my documents folder with the in miscellaneous inside documents. So if I now write this to a CSV file, I can just say iris.csv, and we'll see here that that shows right up in the miscellaneous folder, which is now my current working directory. Okay, so I want to take some questions. Do you guys have any questions about what I've shown so far? Is this making sense?
I get it.
Okay. I just wanted to, because this is kind of the in my opinion, the hard way to do this. So I want to make sure the hard way makes sense first, because this is like doing it by hand. And then I'm going to show you how you do it automatically with R projects. All right, so let's now instead do this with R projects. The first thing I'm going to do is I'm going to make a new project. And I can just say don't save here. I don't need to save any of this. So there's a few ways that you can do this. You can make a new directory that contains an R project. And in this case, let's do it that way. You can also set an existing directory as an R project, which is probably the more common way to do it. But it takes fewer steps. I'm just going to show you how to do it totally from scratch here. All right, so it asks what kind of project do you want to make? There are a lot of different kinds. And if you do like an R package or a Shiny web application, it'll come preloaded with a bunch of scripts and existing tools that will help you get started without too much effort. Same thing with RCPP and a lot of other things in here. This is all relatively complicated stuff. This is really for people who know how to already program in C++, which I admittedly don't know, so I never use these. I've used the Shiny web app one before, and I've used the R package one before. But in our case, we're just doing kind of a general purpose sort of project. So we'll do just a bland new project. All right, so we'll call this my new project. And we'll make it as a subdirectory of, again, this means home. We'll put it as a subdirectory within the home directory. So that it means it's going to be in my documents folder. It's going to be a new folder within my documents folder. And you can actually automatically set up a Git repository with this if you want to use version control with GitHub, or an R environment if you want to basically package everything in a way that makes it reproducible on someone else's system. But I don't really need either of these things right now. So I'm just going to do just bland vanilla R project here. Okay, so what has this done? Well, essentially, if I go to my file system here, which I'll show this to you. So if I go to my file system and I go to my documents and I go to now look at what are the folders in here, I can see that a new folder has been created called my_new_project. And it creates, it has two things in it. It's got my new project.rproj, and it's got .rproj.user. So my new project.rproj is the RProject file. This basically is what the RProject uses to keep track of the settings for the project and also the location of the project. .rproj.user is an interesting hidden directory. The reason I know it's hidden, just for those of you who don't know, is because it starts with a dot, right? So all folders and files that start with a dot are what we would call hidden files. That's because, again, Linux conventions, when you're in Linux, all the files and folders that start with a dot are automatically hidden. To show them, you can actually do this, and now you can see all those hidden files. They often contain configurations or caches, just general things that you wouldn't need to deal with on a daily basis. And so keeping that same convention, all the hidden files and caches and that sort of thing for the R project are also stored in that dot folder here. Does anybody have any questions about that? I know it's kind of like a crazy subject if you hadn't heard about that before. Okay. I think it's really cool because like you can kind of see, like when you start seeing stuff like that, how much like Linux influences how R works and how it's designed. All right, so that's part of the reason why when you're looking here in your file system in RStudio, because it's not showing you your dot files, it's not showing hidden files, it's not going to show you that .rproj.user folder. But anyways, so let's now go ahead and create some data. So I've hit Control-Shift-N to make a new R script. I'm going to call this create data.r. And all it's going to do is I'm going to load up my tidyverse. And then I'm going to write to a CSV. I'm going to write iris to a CSV.
Oh, Henry, can I make a comment?
Sure, go for it.
On the topic of hidden files, if anyone's ever writing some code that's like, say, looping over every single file in a directory, make sure sometimes hidden files can like mess up, like they'll be in there and you don't see them. So just keep that in mind if you're ever doing a loop over every single file in a directory, because I've had annoying things where it's like, hey, I have an image and for every single one of these images in a folder, do this thing, but then it's like a hidden file in there, and I'm like, okay, can I get rid of that? Will my computer break if I get rid of that? Can I move that somewhere? Things like that. Keep in mind.
That is a really good point. Yeah. And in fact, one of the things you can do in Linux to see that, even if you don't have this SFTP panel here, which let's pretend like you've only got a terminal, because unless you're using MOBA Xterm, you don't get that nice SFTP panel. So if all you've got is a terminal and you need to see your hidden files and you need to see what else is in that folder, you can just simply type LL. So this is as opposed to LS. LS is just going to show you in the vanilla way, it's going to show you the non-hidden files. LL is going to show you everything, and it's going to show you like the permissions on those files, and it's going to show you when they were created and how large they are and that sort of thing. So that's my kind of shorthand for seeing what are all the files, including the hidden ones that are in a directory. If I want to do this, if I want to see what's in the let's see here, the Miniconda 3. So I'll do that one. If I want to see what's in Miniconda 3, I can do that by just typing LL Miniconda 3. And again, if you see me, okay, I know I do stuff kind of fast. If you see me ever start typing something and then you see it autocomplete, that's because I started typing it and I hit tab. So tab works in R, tab works in Linux, tab works, I think, in the command prompt in Windows as well. Although in my opinion, not quite as smoothly. But it's just a really nice way to speed up your ability to work on command line. Anyways, so when in doubt, tab. All right, so I've now got my script here that's going to load up the tidyverse library, and then it's going to write iris to a CSV file. And the really nice thing about this is that now I can see it's not had to do anything special to specify my new project directory. It's just known exactly where to write that file without any extra, work. All right, so let's now close this. All right, so I've closed the project. And now what I want to do is let's pretend like I'm done for the day. I've done all my work. Okay, great. Now let's say I want to open that project back up. How would I do that? Well, there's a couple ways, but probably the easiest one is to simply go to the location of that project folder in your file system and just double click on that .rproj file, because that actually is a shortcut to open it up. So we can see it's now done that. It's opened it up directly how I had it last, right here. So everything is where it was, and I can just rerun all my scripts. They'll work just the way they did before. All right. Apparently I lied. Okay, so I guess RStudio does show you dot files, just not the dot folder that we saw before. Anyways, does anyone know what our history is? Just out of curiosity. Has
I
anyone seen that before?
imagine it's all the commands that you type in.
Yeah, exactly. So there's this history panel over here, where it's basically recording your keystroke. Well, not your keystrokes. That would be messed up, but it's recording the commands you enter in the console. And it's going to save those into a file called .rhistory. So you can see that right here. If I click on this file, it'll open it up and it'll show the commands I ran. Pretty cool. Okay, so let's go ahead and make a new file now called read data. So I'm going to load up the tidyverse again. And now I'm going to load the iris.csv using read_csv. And now we've loaded iris into our into our global environment using the read_csv command. Does anybody know what kind of object iris2 is now?
Is it a data frame?
No. Well, actually, in one sense, yes, but in another sense, no. So it says it's a spec table, df, table, and data frame.
So because you use the read CSV function from tidyverse.
Exactly. Yeah, exactly. So read_CSV is a special function from the tidyverse where it does actually read it in. Technically, at its base level, all tibbles are data frames underneath everything else. But they also have another class on top of that manages them and adds some special functions. So if I look at iris2 here, whoops, you can see that when it prints it with these really cool, pretty columns that say, you know, what kind of data type is in each. So it says this is a double character. Kind of cool. But most people don't realize this. Tibbles, which is what this is, tibbles actually are based on the data frame object class. So that's why when you look at the class of this object, you get 4 results back, and then the last one is data.frame. Anyway, it's just kind of cool, some cool object knowledge about R that most people don't realize at first. If I wanted this to be an actual data frame, I could have done read.csv instead, which would have only read it in as a data frame. So now if I do the class of iris2, it says just data frame. And if I print it, it's this gross, long print statement. I don't know. Some people like it better. I prefer to stick to the tidyverse as much as possible. So why is this special? Well, the really special thing about this, and I'm going to show this now. So I'm going to close this project, not save it. The really special thing about this is that what I can now do is I can take this folder and I can try to remember how you're supposed to do this. I guess I can, whoops, send to compress zip folder. I can compress it. I can take it. I can email it to myself, which I'm now going to do. All right. So let's say, here's my work from today. Let's say I want to do this. So let's say I'm pretending like I'm sending this to my boss, right? Okay, so I just sent that to my boss and see when it shows up. There it is. So here's my work from today. So now I'm pretending like I'm the boss. So let's go ahead and save that. We'll save that in my, put that in my desktop, because it's just easy. Extract it. And now I'm pretending like I'm on a totally new computer. So now this is my boss has received this. My boss isn't the one who made this originally. I made it. I sent it to my boss. Okay. And now my boss sees this. They've unzipped it and they've got the project folder here. To recreate everything that I did, all my boss has to do is now just go double click on the R project file. And they're now sitting in the exact same working directory with all the same information, all the same R history. They can literally see everything that I did previously. And now to read in that data, all they have to do is open read_data.r on their computer. And even though they're on a totally different file system, even though they're on a totally different machine, they might even be on a different operating system. This will still work exactly the same way that it worked on my computer. And they're able to take that data, they're able even to add something new to it. So let's say they wanted to add, now they want to add plot data.r, they want to add that. So they read the data. Okay. Let's say they save it. They save it as RStudio.rda. And now let's say they want to make a file that plots it. So they load iris2.rda. And then let's say they do need to keep loading that tidyverse library here. You don't actually have to. There's a way to get around it, but I'm not going to show that. So let's do that. X is sepal length. And Y is sepal width. And color is species. And now they're able to make a really nice plot, which they can save. And all of this happens same directory. So now they're done making their changes and adding to it. Okay, they finished their work. All right, and so all they're going to do now is close this stuff. They don't even have to close it, but they'll close their project. Don't save. And now that they've made their changes, they can just take this, zip it up again, and just send it back to me. And that we can just keep repeating the process back and forward. And there's no need to, as you'll see many people do, and I'll just show this here. There's no need to ever say, set working directory, my folder, my other folder. There's no reason to ever do that, because all the relative file paths are always correct as long as you're working in that R project directory. All right, so that's the main utility of the R projects from my opinion. Do you guys have any questions about how this works or how I'm using this here?
It's pretty neat, and I know for people who maybe don't know R, and you're like used to a different coding language, and like you try to copy a path, if you're on Windows especially, into R, it's extremely annoying. And Henry, you may want to showcase this, what I'm talking about.
Yeah. Okay. So you're talking about like
If you go to the File Explorer and then you copy a path and then you
oh,
paste it in R.
yeah, I know exactly what you're talking about. All right. So let's say this is a
That's my main motivation to using R projects, is to avoid all that nonsense.
yeah. So let's say that for some reason I am feeling adventurous and I want to analyze some single cell RNA-seq. Okay, so I've got some single cell RNA-seq data in this folder all the way over here. And this folder is very deep into my file system. It's pretty far in. It's many layers, many layers. I'm not even entirely sure how far in it is. So it's okay. Yeah, there it is. So this is the entire path. Users, Miller, Boxing, Henry Miller, Miss with a weird thing in it, Bioinformatics Bootcamp Workshop, Single Cell RNA-seq Workshop, Module 5 Advanced Topics. This is the full file path to get to this point. The way that people typically will try to get one of these files, if they need, for example, this choi9 matrix.csv.gz, what they'll typically try to do to get this is to go to properties. And then what you would attempt to do is copy this location here. Okay. And then let's say I needed this. So let's say I'm going to make a new file, and this is analyze scRNA-seq. Because we've jumped a few levels of complexity now. My data. And so you can do this and paste that file path. And then like one layer further. Okay, let's see here. So this is the file path I just copied. And then the last part is I need the actual file name at the very end. So let's rename. This is my trick. Rename and then just copy this and put this at the very, very end. Does anyone want to take a guess as to, well, no, I'll set this fully up before we do this. So my data, and then I'm going to try to do just like I was doing before, library tidyverse. Oh, wait, actually, I have this set up so you actually need to do read.csv for this one. So I'll do read.csv on this one. I remember how I constructed this. It has row names. So fun fact about Tibbles, they can't have row names. Or at least not really. You really shouldn't use them. Okay, so it's a CSV and it does have row names. They're on the first column. So I'm going to say row names is 1. So I'm going to try to read this in. My data matrix. If I attempt to run both of these lines, does anybody have a guess as to what would happen? Does anybody know what the problem here is? Anyone except for Victor, who I know knows what the problem is. So I want to point something out.
This might be really dumb, but is it that the first row, is it just way too long for it to read?
No, that's not dumb, actually, because that does happen. That does happen. You can have a file path that actually is too long, but no, that's not the reason this time. So I want to give you a hint, which is notice the direction of the slashes here and here.
So it has to do with the slashes, right?
Yeah. So does anybody have a guess as to what the problem with the slashes is?
They're facing the opposite way.
Well, yeah, they're facing the opposite way. But go ahead.
Is it like a formatting issue, like the slash and then a character is supposed to be some kind of formatting in between quotes?
So I wanna show you something. So I've already mentioned a couple times that R and the RStudio environment are very like Linux driven. So when we make file paths in Linux, let's go ahead and do this here. So let's say I want to go into Miniconda, and then I want to go into, oh, okay, another trick that I just used without thinking. If you're staring at something like this and you you are right after a slash, or even if you don't have anything, whoops, my bad. Even if you don't have anything here yet, if you just hit tab twice, it'll start suggesting options for you. So mini counter 3, autocomplete, double tab to suggest options, conda bin, conda bin, double tab to suggest options, which there aren't any. So I'm going to go back to ENVs. Double tap to suggest options, and so on and so forth. So as I'm building this path here, what you'll notice is that all the slashes go forward. They're forward slashes. In Windows, if I go to my command prompt, which is a DOS based thing, so Windows does stuff based on DOS, which is kind of like the worst version of Linux, in my opinion. Basically, you can see here that when I double tab, it starts suggesting options. But okay, I'll actually start going forward here. So let's say I want to go to box sync. Okay, CD box sync. You can see as I'm building this path, it's building them with backslashes. And also, you don't double tab in DOS. If you can just do a single tab and it'll start suggesting things. So it's building them with backslashes instead of forward slashes. So we're now getting into what is the fundamental difference between how you operate in a Linux environment. Well, okay, there's lots of fundamental differences, but one of the fundamental differences between how you operate in Linux versus how you operate in Windows, which is Windows likes to use backslashes for paths, and Linux uses forward slashes. And as silly as that might seem, it's actually a huge problem when you're in R. Because if I try to run this, let's see what happens. Does anybody have a guess as to why it just gave me this error? So it says error /u used without hex digits. So, okay, I know that probably seems really cryptic, but the reason is because in R, backslashes within quotes has a meaning, a very particular meaning. And it actually means something called escape. So when you do a backslash in R, it thinks you're trying to give a special command that tells it to do something special. Okay, so there's lots of escape commands you can give. /u is one of them, and that's why it's complaining here, because it thinks you were trying to give a special command. Or I can say they wouldn't be called escape commands. They're a particular kind of command that you can give. To escape, okay, let me put this another way. Escaping means that you get out of that mode. So we're going to escape this by putting a second slash. And so you can see here that it thinks I'm trying to give a command, and it thinks right now I'm trying to give the command /quote. And so basically that's why it started going crazy here. It's very upset that I've done this. It thinks that there should be something else that follows this, but there isn't. If I want to escape that, I can actually just put another slash, and then it kind of negates itself. So I can run that, but I can't run this. If I try to run this, it'll actually get confused and think I'm trying to run this whole line, and then it doesn't know when it ends. So that's part of the problem here. If I do, does anyone know /t? Oh, does anyone know what /t this command signifies?
Is it tab?
Yeah,
tab?
exactly. It's tab. Yeah. So this signifies a tab character. Yeah, that's an often thing to use. That's often used in Linux, actually, is to signify tabs. But anyways, so that's the problem that we were talking about. If you actually want to get a file path from DOS to the Unix or Linux system, you actually have to go and replace all this stuff with yeah, that's right. Okay, with forward slashes, then you take away the C thing. So yeah, anyways, not a good use of your time. Really not a good use of your time. Anyways, so if I wanted to get this data set, the easiest way for me to do that is honestly just to take it and copy it and paste it into my project directory. So my project directory now is in desktop. So I'm going to copy this, paste it, and now it's right here. So instead of all that nonsense, I can just point my data to this local file right here. And this will always be, as long as this is always contained in the same directory, it'll always work. And I can just go ahead and now read this in. Not that that's a great idea because it's a very large data set. Well, for single cell, it's actually a pretty small data set, but for our purposes, it's pretty large. It's 1,200 columns by 33,000 something rows. But anyways, so that's in essence the basics of why you would use a project. I can now zip this up, send it back to my colleague, and they can do the exact same thing. One final note, and I just wanted to demonstrate this, was that if you start a new project and you already have a directory where you want to access a project in, you can actually just select it like this. So let's say I wanted to create a project out of some pre-existing directory on my computer. So let's say I want to do one in this, I don't know why I would, but in this IGV folder here. Simply do this and it'll generate the project for me. And so now it's added igv.rproj, and I can see all the files that are in that folder, and any R scripts or anything I had here will be displayed. All right, let's close. Oops, let's close that. So do you guys have any questions or any comments about what I showed here?
Henry, I have another comment to make.
Go for it.
So that issue with those Windows path and it not being kind of like by default, just copy and pasting doesn't work. Python also, for those of you who may know, Python also has a similar problem with the Windows paths and stuff. But in Python, it's easier to fix. You just add a little R right before the path, and that makes it so it's able to read it. And if anyone's curious or is aware of that issue.
Nice. I actually had no idea you could do that. Let me see if I can switch over to Python and show that really quick here. Oh, never mind. I don't have it installed on my system yet, so whoops. But yeah, if I had it installed on my system, that would have been really cool. Do you guys have any other questions or comments?
Yeah. So I've noticed every time you close your project, you don't save. I just want to know if you're actually losing anything if you don't save.
So the thing that makes R kind of different from most other programming languages is that it's based around the concept of environments. It works, R works pretty much entirely in memory. Okay, so typically everything is done in environment. Sorry, this is probably kind of distracting. Okay, so yeah, it works pretty much entirely in environments. So when you create something in your environment, it gets saved in memory. And oftentimes people are doing analyses and they want to save their workspace, which basically means all the things they had in memory, they want to save them to the disk so that next time they load up that project, all those things that they had been working on last time get automatically loaded back into memory. And so that's what it's basically asking you every time you close your project. It's asking you if you want to save an R data file. And the R data file is how you save your environment in memory. Or sorry, save your memory. The environment you had in memory, save that on your disk. That's how you do it. But yeah, okay, now I've got Python working. So let's just show this as an example here. I don't know why it's been, okay, there we go. So we'll make a new object. A is 1, B is 2, C is A plus B. So we've created 3 things in memory now, A, B, and C. These are 3 things that are now in our global environment. So if I exit, well, okay, so I should have been in a project when I did this. Let's just do this here. Because it still just take a second. So let's do that again. A is 1, B is 2, C is A plus B. All right, so now let's go to close this project. And then instead of saying don't save, we'll actually save this. All right, now open that project back up. And when we open it up, it's now loaded A, B, and C back into my memory because it saw that that was available, that there was a .r data file available. And because it saw that, it said, okay, so when you open this project, what you need to do is you need to load all the objects that are in the .r data file back into memory. And that's essentially what we did here. These can get kind of inconvenient if you have a ton of stuff in memory because it will load it every time. And sometimes you don't want to wait for everything to load back into memory, depending on how much you had saved in this file. But it is convenient if you want to share your data with someone else and you don't want to have them do anything special to recreate the environment that you had on your computer, on their computer. Okay, so I got one question here, which is, which do you prefer personally, Python or R? They're really very different, and I use both of them for totally different things. I use R probably 70% of the time because it's much faster for me to do my analyses in R. Python is a more robust language for programming and for building things like web application backends and that sort of thing. So they're totally different languages. And the nice thing about RStudio now is that you can actually write Python pretty satisfyingly in RStudio at this point. So I can natively write Python now in R. So if I wanted to write a Python script, it's really easy for me to do that. I can do import pandas as PD, which I suppose doesn't work because I don't have pandas on my computer yet, but I can do so write some Python. You know, I'll do something like this. So I'm actually writing Python code and interacting with it the same way I was interacting previously with R. So that's kind of the nice thing about RStudio in its latest iteration is you can write Python very easily. But yeah. Okay. Well, so we've gone a little bit over time now. Sorry about that. Does anybody have any quick questions before we break?
So Henry, I have one question.
Sure, go for it.
Does it mean that we can have Python and R in the same R script, or it has to be a different script?
You actually can have Python and R in the same R script, but you do that through kind of a special way using the reticulate package. It's easier to keep them separate, though. In my opinion, it's easier to keep them separate, but you can combine them. And in particular, R Markdown, you can have, if you're writing R Markdown, so I'm just going to make an R Markdown here. I can easily make R code chunks, and then I could easily make a, down here, I can make a Python code chunk as well. That also runs using Python. So I can mix and match them in R Markdown very easily.
Oh, okay. That's great. Thank you.
Yeah, no problem. All right. Well, thank you guys so much. Sorry for going over time. If anyone wants to present next time, feel free to do so. If you could let me know ahead of time, just for like scheduling purposes, that would be awesome. But yeah, I'm happy to also go over your presentation with you if you want any feedback on it before you present. Because I think these are not easy to put together. And I would definitely be happy to help you do that if you want any help. So with that, thank you all so much for your attention, and I'll see you all next week. All right. Y'all have a good one.